Hello everyone. Today we will talk a bit about voice control. Uh, what do I mean by voice control? Everyone who using mobile devices, mobile phones, I guess know about Google Voice services. When you say OK Google and saying some command. In total, this task is solved, and people still working in this direction, not only by Google, a lot of companies working on it, but first of all I will tell you about basics of voice recognition, absolutely basics, and I will explain you why existing, at least popular libraries which recommended for Python is not always useful for actually voice control. Okay, of course voice is a sound. So for sound you can use some libraries. One of them can be used at it's PyAudio library. For getting data from your recording device. I'm sure that there are more libraries, but this one is good enough for getting audio data. Now, I will not explain now, show you code and so on how to get such things, because it's not a goal of this video. What finally you get on input. On input you get a waveform, let's say power of sound. It is upper image, let me show you. Sound power. This one. This one upper image is how loud sound, how loudly you talk, when you're speaking and saying some words, some sounds is not so loud. Some sounds like A, O, and some others, they sound louder comparing to, let's say, well, yeah, well, let's look at, well, not so loud sound. It sounds like usual noise. That's all. So first you get using this library or some other library, you get this data. Then basics of voice recognition is actually a spectrum of sound. It means what frequencies used, what frequencies let's say not used, let's say it's frequencies. Over here, the highest point is main tone, and sometimes you have in sound one more, you can have 3 or 5 or more such extremes, they called overtones, and this is actually how your ears work. What am I mean? In ear we have set of very little soft bones, and they have different lengths, and each of them react to exact frequency. Then our brain analyzing this data, and we can understand what sound we hear, or we hear O, or we hear A, or we hear I, or we hear, I don't know, I'm calling letters, but sounds, I hope you can hear me. And this is base data for latest voice recognition. Matter is that let's back to our we have time. Sound goes over time, and we need to know this spectrum for each, let's say, moment or separate range of time. For that, usually sound dividing into short sequences. Many systems, at least one of recommended approaches is this one. We dividing our waveform into pieces by length of 25 milliseconds, and we divided them into pieces not let's say first from 0 to 25, then from 25 to 50, we're making step. So first we taking range from 0 to 25, then we taking range from 10 to 35, and to remove let's say to make our program more be concentrated on range we choose. Edges of this range, power or sound, I'll lower it down there, and as a result we getting some picture with maximum at middle of our range, and then we analyze it again. I'm showing you a picture. We analyze it by this one. Now, what we know, let's say, in one range 25 milliseconds, we know approximately what sound microphone recorded. But we need a picture, we need to know what was said over time, to because words is sequences actually. So we need to mix it somehow, and mixing it this way. We have spectrum by on x axis It is frequency, and color shows power of each frequency, and on x-axis it's a time. So it's a basics actually how it's done. Then it starts to work with neural right now. Actually, it's in common. It's a signal processing task, and now most used approach is neural networks, neural nets, and there are now a lot of them. There are a lot of different ways. It's a whole world of and why it is problem sometimes to make what you need in Python. Why not simplest, let's say, more common way, which actually you can find on YouTube. It is speech recognition library. This library using it is online library. It means it using actually services and algorithm which running on other machines, and you just use an IP to send your data to remote server. Then server analyze your phrase and trying to remove to return your text you said, and if text recognized, you get text. But let's look what the problem here. First of all, most of there is also there are also several libraries such as for example as far as I remember, so this one library is offline library, so you can use it on your computer. This one, if you have some slow internet connections, first one will work sometimes will not work, will work with delays and so on. Most libraries have some problems for some tasks. We're talking about task of just controlling your program or other programs. If your program interact with other programs by maybe by TCP, UTP protocol, or using such libraries as PyApple, and or as I said, one of ways is TCP UDP interaction. So you have program which trying to catch commands from your voice, and when one of commands said, it should activate something, should make some action. Why using these libraries is not always easy. First of all, they are oriented to speech recognition. What does it mean? They have vocabularies not sure, sorry, English not native. I hope okay. Let's call it dictionary. Dictionaries. Yeah. About 100,000 words. Each trying first disadvantage. I am not saying at all that it is bad libraries. They are maybe good for for tasks they created for, but they not always good for task of simple voice control. Because usually let's say you use your dictionary can be 10 words. That's it. You don't need a huge amount. You're not going to create speaking bot or something else. All you need, your program is react to